This is an interesting project where my graduate student who recently got his PhD, Isaac McWan, and my master students, Jie Zhao, popularly known as Thomas, have been working. So they're working on a bacteria. So they're basically bacteria people, we call him. This bacteria is magnetotactic bacteria, very smart. They can be navigated by magnetic field. So what this group of students do, they do some innovative approach of attaching an electronic component with this bacteria and then making it move and then deposit the electronic component at a precise location. In addition to that, they manipulate this bacteria through its crystals, because the bacteria has 20 to 30 nanometers crystals in its body. These crystals grow in the body of this bacteria. Those crystals are catalysts for many nanostructure growth. So we are coming up with a species of this bacteria which is called Magneticum magnetospirillum. They are called AMB1. With that species, we are using several approaches to use the species to come up with next generation nanolithography. And this process we call as magnetotaxis-based nanofabrication. So here my student Thomas is going to show you some of the nice demonstration as to how these bacteria can be used in electronic fabrication, in electronic navigations, and also at some point the crystal that is derived by the bacteria is used for hyperthermia application for cancers. So here is some of the experiments that Thomas is going to show.
We are working at the magnetotic bacteria. This bacteria is very special and it can follow the magnetic field. The experiment is we culture this bacteria in different medium. So we have a solid medium and liquid medium. Over here. So when we look at the microscope, we can see a very interesting thing about this bacteria. Our goal is to use electro wire to produce a magnetic field to control this bacteria and to let them to carrying nanomaterials and deposit at specific positions. So right now, let me show how this bacteria works. As you see, this is a bacteria with a medium. We are located a magnetic field, a permanent magnet, and we try to use this magnet to control this bacteria. Let's see, this bacteria is following with this magnetic field and going higher and higher. By manipulating this bacteria, we are planning to develop bioelectronic and computer chips.